Hi coders, CS Time channel here, and this video discuss about Introduction to Circular Singleton List, Memory Representation of Circular Singleton List, Operation in a Circular Singleton List, Creation of a Circular Singleton List, and Traversing Circular Singleton List. This image shows how the circular list is being stored in the memory. The start or the head of the list is pointing to the element with the index 1. Index 1 containing A in the data part and 4 in the next part, which means it is linked with the node in the index 4. Index 4 containing data B and 6 in the next part, which means it is linked with the index 6 containing data C and 8 in the next part. This is also mean it links to the index 8 containing data D. However, due to the fact that we are considering circular linked list in the memory, therefore the last node of the list containing D, the next part is the address of the first node of the list. The operation in circular singleton list includes traversing, searching, insertion, and deletion. And the focus in this video is creation and traversing of circular singleton list. Now let's see how to create a circular singleton list. In the situation where our circular singleton list is empty, our circular singleton list will look like this. The head point to now. And if you wish to insert a node into current circular singleton list, it will look like this. We hold the node in a variable called temp. The node consists of data A and the next part. The next part point to null. So to insert it to the current circular singleton list, we have to pay attention to the pointer belong to the head. We instruct the pointer belong to the head to point to the temp. And now we instruct the temp pointer to point to the head. By doing like this, our circular singleton list will look like this. Suppose you wish to add another node to this current circular singleton list, then the same process happens. Say we use temp again as the variable to hold the new node, and the new node contains data B and the next part point to null. Then if you wish to insert this new node to the current circular singleton list, then we have to pay attention to the temp.next. The temp.next we instructed to point to the head like this. And now, pay attention to the next pointer belong to the head. We instruct the next pointer belong to the head to point to the temp. By doing like this, our current circular linked list now become like this. Now, let's see how to do traversing in a circular singleton list. From the creation of the circular linked list just now, assume we have this circular singleton list. So, if we want to traverse it, at first, we have had pointer that point to the node that consists data A. To be able to traverse it, we need the help of another pointer. Here, I will use tail. I assign tail to point to the head.next. By giving this instruction, our circular singleton list will look like this. Tail point to the head.next, which is here. We need to instruct the tail to keep on moving to the next node until it reaches the head. Therefore, we need this instruction. Tail equal to tail.next. By doing like this, our tail pointer will move to the next. We want to instruct the tail to keep on moving to the next until it reaches the head. To do that, we need to wrap this instruction under looping. So I will wrap it under while. So the condition to do that is while head not equal to tail, we instruct the tail to move to the next node. Tail equal to tail.next. By giving this instruction, our visualization will look like this. Once it's reached the head, this condition fulfilled. Then the traversing process stop here. Let's see the Java implementation. Here, I created a class with name circular singleton list. First, I will need a pointer that point to the node. So here, I will declare private, and then the node itself, I will name it as circular sing list, and then the pointer will be head. so the head will point to the first node of the circular string list. I will also need another variable that I declare as private integer length to know the size of the circular string list. Now I will create the class for the circular string list here. I declare it as private class. This circular string list will have two parts. The first part is next that I declare it as circular string list to point to the next node, and the second part is the data itself. Here I will declare it as character because our data will consist of character. Now I will create the constructor method that I declare it as public circular string list, and the parameter will be the data itself that I declare it as character. So now I will initialize the data with the data from the parameter. Now I will create the method to initialize these two variables, the head and length. I declare it as public circular string list, and I will initialize the head with null since head still point to nothing. The length is 0 since our circular string list still empty. Next, I want to create a method for the size of the circular string list. Here I will declare it as integer. It will return the length of the circular string list. Another method that I need here is for returning Boolean value if my circular string list is empty or not. So it will return true or false. It depends to the value after checking. Now I will create the object for circular string list. The name here circular string list. The next job is to do the creation of the circular string list. I will create a method that I declare it as public void create circular string list here. I will just copy here. The first object I will call it as first, and then the data that I want to create is A. I will copy this 4 times. Change the data. And then the name of the object. Now we have 4 nodes with 4 data A, B, C, D. Up to this, the node is still individual node. They are not connected. Now we will connect it. We instruct the first to point to second, instruct the second to point to third, third to point to fourth. Since this is circular string list, we will tell fourth to point to first. By doing like this, they are all connected, and we need a pointer now to point to one of the nodes. So our pointer on top is head here. Then we will tell head to point to first, like that. So this is the method on how to create the circular string list. To be able to test or to see the result, we need to create the display method. So here I will write display method. I declare it as public void display method. According to my explanation just now, there is possibility that our circular string list is empty, which means the head point to null. So the first job is to check if our circular string list is empty. Then we will check if head equal to null, it means it's empty. When it is empty, then it will do nothing. The second situation where our circular string list has nodes. To be able to traverse it, we need the help of another pointer. In my visualization, I use tail. So I will instruct tail to point to the head dot next. I instruct tail to point to the head dot next. That's according to our visualization. The second pointer, which is tail, is in the second node. Then the first node to display is the head. So I will display the head here, head dot data. Now we want to traverse all the node. So we need a looping to traverse from the beginning till end. So tail will move from the node pointed by the tail until the tail meet the head. So the condition to check is while head not equal to tail, the tail to keep moving to the next node. By doing like this, we tell the tail pointer to keep moving to the next node as long as the head not equal to the tail. Before tail move to the next node, we will need to print the data pointed by the tail. So here, we will just display tail dot data. For the purpose of visualization, I will include a row sign here to show the connection. Now we can call this from the main method CSLL dot the method. The second one is CSLL dot display. Now let's see it one more time. Under the class circular singly linked list, I have one pointer as well as one variable to hold the size of the circular singly linked list. And then I created the node using the name circular sing list, and the node has two parts: the data itself that I declared as character, and then the next pointer that I declared as the node itself. And then I initialize the data. I also initialize the pointer with null, since in the first situation the pointer point to null. When our circular singly linked list is empty, the head will point to null, and since it is empty, then the length initialize with 0. And then we also have a method named length to return the size of the circular singly linked list. And also we have another pointer to check if our circular singly linked list is empty or not. If it's empty, meaning the length equal to 0, then it will return true. Otherwise, it will return false. And then now we have to create the method to create the circular singly linked list. So to create the circular singly linked list, at first I created 4 nodes. The node that consists A, and then consists B, and then consists C and D. So I have 4 nodes. Up to this, our node is still stand alone, or there's no connection with another node. To make them connect to each other, then I instruct the first to point to the second point to the third, and then third to the fourth, and then fourth to the first, because it is circular singly linked list. And then now we instruct the head to point to the first node. To display it or to traverse the circular singly linked list, we check the possibility. The first possibility is when our circular singly linked list is empty. We know if it's empty when head equal to null. In this situation, we do nothing, or we don't do the traversing. When our circular singly linked list is not empty, then we can start reading the circular singly linked list. To be able to read it, we need the help of another pointer. So we will have 2 pointers. The first one is head, the one that we had, and the additional one is tail. We instruct the tail to point to the head dot next, or the second node. Since our job here is to traverse it, then we will display the first node, which is pointed by the head. That's why here we print head dot data. In the second node, we have tail. Now we want the tail to traverse from the second node until the tail meet the head. To tell the tail to keep moving to the next node, we give this instruction: tail equal to tail.next. And the tail will keep on moving to the next node as long as it doesn't meet the head. So we need to wrap this instruction under while loop, and the condition is while head not equal to tail. So as soon as head equal to tail, it will quit the looping. It means we are done with the traversing. Let's see the result. Here is the result. If you learned something from this video, please subscribe and like for more videos. Thanks for watching.